Most dev teams ship their app, cross their fingers, and hope it doesn't fall over when real users show up. They run their functional test suite, everything passes, the staging environment looks good, and they hit deploy with confidence. And then the launch happens. Traffic spikes. The server starts struggling. Response times climb from 200 milliseconds to 3 seconds to 8 seconds. Users start seeing errors. The database starts timing out. The on-call engineer gets paged at 2 a.m. The team scrambles to roll back or scale up, and by the time they stabilize things, thousands of users have had a terrible experience. This is not a rare edge case. This is one of the most common and most preventable failure modes in software, and it happens to teams at every size and maturity level. Load testing is how you prevent it. It is not optional. It is not something you do once before a big launch as a checkbox exercise. It is a fundamental discipline that belongs in every mature QA practice. In this series, we are going to build the discipline from the ground up, starting right now with what load testing actually is, what it tells you that no other type of testing can, and why the vast majority of engineering teams either do it wrong or skip it entirely. Load testing is the practice of simulating real user traffic on your application to observe how it behaves under pressure. Let me be precise about what that means. You're not checking if the app works correctly, you already know it works for one person. Your functional tests cover that. What you don't know is what happens when 100, 1,000, or 10,000 people use it at the same time. Does the response time stay within an acceptable range? Does the server start dropping requests when the connection pool fills up? Does the database become a bottleneck because every request is hitting the same table? Does memory usage climb steadily until the process crashes? These are questions that functional testing cannot answer. They only surface under real concurrent load. Load testing is the discipline of creating that load artificially, in a controlled environment, before your users create it for you in production. The key word there is controlled. You get to decide how much load, how fast it ramps, how long it runs, and what success looks like. That control is what makes load testing so valuable. Every load test produces a lot of data, but there are 3 numbers you absolutely need to understand. The first is response time, but specifically the 95th percentile, not the average. Averages are almost always misleading in performance testing. Here is why. Imagine your endpoint handles 1,000 requests. 950 of them respond in 100 milliseconds. 50 of them take 5 seconds each. Your average response time is about 340 milliseconds, which sounds fine. But 5% of your users, 1 in 20, waited 5 full seconds for a response. That is not fine. That is a terrible user experience. The 95th percentile, or P95, tells you what the slowest 5% of your users are experiencing. It is a much more honest representation of real-world performance than the average. The second number is throughput, how many requests per second your system can handle. This tells you your capacity ceiling. The third number is error rate, the percentage of requests that failed entirely. A system that is slow is frustrating. A system that is returning errors is broken. All 3 numbers matter, and you need to track all 3 together to get a complete picture. So if load testing is this valuable, why do most teams never do it? There are 3 reasons I see over and over again. The first is ownership. Load testing sits at the intersection of QA, development, and infrastructure. Nobody feels clearly responsible for it, so it falls through the cracks. QA engineers think it's a DevOps concern. DevOps thinks it's a QA concern. Developers think someone else will handle it. The second reason is perceived complexity. Setting up a realistic load test requires scripts, test data, an environment that resembles production, and some understanding of what realistic traffic looks like. That feels like a lot of upfront work. The third reason is a false sense of security from cloud infrastructure. Teams assume autoscaling will protect them. And autoscaling does help, but it doesn't eliminate every bottleneck. Your relational database doesn't autoscale horizontally. Your third-party payment API has rate limits that don't care about your scaling policy. A poorly written database query that does a full table scan on every request will bring your system to its knees at 50 concurrent users regardless of how many app servers you spin up. Load testing finds these things before your users do. In this series we are going to use 2 tools, and I want to give you a quick preview of both so you know what is coming. The first is K6, made by Grafana Labs. K6 is a modern, developer-friendly load testing tool where you write your test scripts in JavaScript. Under the hood it runs on Go, which means it is extremely fast and resource efficient. A single laptop can simulate thousands of virtual users with K6. It runs from the command line, integrates cleanly with CI/CD pipelines, and produces structured output that you can send to dashboards and monitoring systems. It is my go-to recommendation for most teams starting with load testing today. The second tool is Locust, a Python-based load testing framework. Where K6 defines user behavior as a JavaScript function, Locust defines it as a Python class. This makes Locust extremely flexible for simulating complex, stateful user journeys. Think multi-step workflows where each step depends on the result of the previous one. Locust also has a built-in web UI that lets you run tests interactively, which is great for exploratory testing. We will cover both tools in depth, and by the end of this series you will know which one to reach for depending on what you are trying to test. Load testing is one of the highest value skills a QA engineer can add to their toolkit right now. Here is why that matters for your career. Most QA engineers know functional testing. Manual testing, automated UI tests, API tests, that space is crowded. Performance testing and load testing are different. They require you to think about systems under pressure, to understand infrastructure constraints, to communicate findings to both engineers and business stakeholders. Relatively few QA engineers have that skill. The ones who do get pulled into architecture discussions. They get asked to sign off on capacity planning decisions. They become the person the team calls when something is slow in production and nobody knows why. That is a very valuable position to be in. In the next episode, we are going to write your first K6 script from scratch. No prior experience required. We will install K6, write the script, run it, and read the output all in one episode. Subscribe so you do not miss it, and drop a comment below if your team currently does any load testing. I genuinely want to know where people are starting from. Before we close out this episode, I want to give you a concrete picture of what load testing looks like in practice at a real company, because the abstract explanation only goes so far. Imagine a mid-sized e-commerce company preparing for their biggest sale of the year. Their engineering team knows peak traffic will be roughly 5 times their normal daily average. They have a functioning CI/CD pipeline, a solid automated test suite, good monitoring and production. But they have never run a load test. A week before the sale, the QA team runs their first stress test. They discover that the product catalog API, the one that every page load hits, starts degrading at just twice normal traffic. At 3 times normal, it is returning errors. The root cause turns out to be a database query that fetches the full product record including all images and metadata for every API call, when the catalog listing page only needs the name, price, and thumbnail URL. That query was written 2 years ago and nobody had noticed it because at normal traffic levels it was fast enough. Under load it became a catastrophic bottleneck. The fix took a developer 4 hours. Without the load test, this would have been discovered by real users during the sale, likely taking the site down during peak revenue hours. That is the value of load testing in concrete terms. 1 test. 1 finding. Potentially millions of dollars in prevented lost revenue. That is what we are building toward in this series.